Hi, my name is Bryan. So I'm a research software engineer on the land surface modelling team at ACCESS-NRI. I'm going to be talking about BenchCab, which is a scientific evaluation framework for the cabled land surface model. So for this talk, I'll just go into the why and what we did and basically the next steps forward. So firstly, going to introduce you to why we need a testing framework for cable. And throughout most of cable's history, there wasn't really a formalized process for researchers to contribute code to the model. And there was a question mark around what sort of testing and evaluation was required when making new code changes to the model. This led to a lot of ad hoc testing and evaluation of the model, and this is problematic for a number of reasons. Often the level of evaluation would be dependent on the expertise of the developer. An ad hoc analysis might overrepresent positive effects in simulations and can be susceptible to confirmation bias. It also raises the question around reproducibility. So it can easily turn into an "it works on my machine" scenario where instead of a machine, you have like a test configuration that's being used. And also, if you're doing an ad hoc analysis, the results you produce might not be comparable across institutions. And the test configurations you might use might have limited test coverage in the model, and you might find that your code changes might inadvertently break other configurations. So this sort of leads us to BenchCab and modelevaluation.org and how we use these tools to provide a standardized science evaluation framework for cable development. So just starting with modelevaluation.org, as we saw earlier, it's a web application for evaluating and benchmarking computational models. And it was developed by Gab Abramowitz and his team at Klex UNSW. So yeah, with modelevaluation.org, users can choose a standard experiment, download the driving data, and then run their model in their local environment. And then the user would upload their model output to the platform and then run an evaluation that's available on modelevaluation.org. So BenchCab fits within the running your model locally part. It's a Python-based command line tool that's developed by our team at ACCESS-NRI, and it basically runs cable across several standard model configurations and integrates with modelevaluation.org for the scientific evaluation. So with a single BenchCab run command, it passes a user configuration file. It checks out the model version specified by the user that they want to test. It builds the required executables and then runs each model over the standard cable model configurations. So as part of the testing, BenchCab runs a set of 42 offline flux site configurations, and these are configurations where cable is run over a single point on the globe, forced with meteorology coming from observed flux tower data. So for each of these sites, BenchCab runs the model versions specified by the user, and also runs each model for each site over a number of science configurations to get as much coverage over the model as possible. It also has some additional testing features, such as a regression testing capability and generating code coverage analysis. For the scientific evaluation, we're using a site-based benchmark analysis based off the Plumber 2 model intercomparison project. So in this analysis, results are plotted for several statistical metrics and allow the user to compare how their model performed with respect to other model versions to assess the model improvement. And you can also compare it against out-of-sample empirical models, and this is useful to gauge the level of improvement we could expect from an ideal land surface model. So what are the aspects that went well with this approach? Well, one of the positives is that we improved the test coverage in the model. So BenchCab runs a test case runs test cases against several configurations of cable, and this decreases the chance that we have inadvertently broken something in the model and improves its reliability. It's also now having standardized evaluation available to the community is extremely beneficial and lets us further develop the tool as a community, and so that all the developers of cable can benefit equally. And with the analysis, it's very easy to see the impact that your code changes have, and can be easily seen from the evaluation on modelevaluation.org. Another positive we found was the regression testing capability. So when the bitwise comparison of your model output, it really informs the developer of when and how model outputs differ from a set of code changes. It's very easy to test new model features in this with BenchCab. We're using its nameless configurability features, where you can switch on any sort of science option at runtime. And it's easy to reproduce other people's test configurations, and you just have to share a version-controlled configuration file. Some of the things that didn't work so well, currently to kick off the evaluation step on modelevaluation.org, the user needs to manually upload their model output via the web interface, and this is as a massive overhead to the user, especially when you have a large amount of files. And the test configurations are by no means comprehensive, and there are many edge cases currently not being tested. BenchCab, it's also only supported on Guardi HPC, which is problematic for our external collaborators who want to contribute code. And it's also primarily designed around cable, and currently cannot test any other lab service model. So for the next steps, our first priority is to address the manual upload problem to modelevaluation.org and effectively have this process entirely automated. So our team and the team at the UNSW have been working on developing a web API around modelevaluation.org, as well as an API client called MEOR client, which is developed by my colleague Ben Schroeder. And this is so we can programmatically upload and interact with the web service from a local environment. And this will minimize the overhead for the user significantly. We also want to improve the evaluation capability on modelevaluation.org. We want to integrate ILAM for evaluating spatial outputs, as well as hierarchical analysis, which allows the user to see more fine-grained details in the model output, in addition to the statistical aggregate metrics. We also want to broaden the model test configurations. We want to include the CASA-CMP biogeochemistry, as well as more unique sites such as urban, lake, or ice points. We also want to have users to be able to run BenchCab outside of Guardi, so that external collaborators can contribute code to cable in the same way. And we would also in the future like to extend BenchCab to test all other kinds of models other than cable, and this is due to an interest from several international modeling groups, which are listed in the slides. So to summarize, BenchCab and modelevaluation.org are the tools for the cable community to test and evaluate the cable model in a standardized and systematic way. And this is so that model development is reliable and reproducible. And you can find out some more on the links above there. And I'll open the floor now to any questions, but that's concludes my talk.
I think it would be, has it been written to be easy to port to other models, or is it a bit?
Yeah, so not really. It's kind of, I only had cable in mind, so that's sort of like a bit of technical debt we've accumulated. But the functionality, in my opinion, isn't that complex, so I feel like it would be quite easy to make it more generic.
Yeah, could you just explain again what you mean by regression testing? I wasn't sure what that is.
It's, the regression testing happens when you run BenchCab with multiple model versions. So let's say you run, you specify like the main version of cable and then your feature branch of cable. If you enable the regression testing feature, it will compare all the experiments run by these two versions of cable and then it'll compare those. So if you make a change, say in your feature branch, that you don't expect to affect the results, then the regression test will do a bitwise comparison between the model outputs for all those experiments and tell you whether something has changed.
We have a question from Kim Reid online. So Kim is asking if model output, considering that model output can be quite large, if various groups are uploading their outlook to the same place, presumably modelevaluation.org, how is that being stored, and is that a big challenge?
I don't think I can answer that question. Maybe, I know the guy I mentioned, Gavin, he's sort of like the lead developer of modelevaluation.org. But as far as I understand, it's somewhere on NCI in like an object store. So if anyone knows anything about that and its limitations.
Perhaps that's something that someone else can answer on the chat as well. Thanks.
Thank you, that was a nice talk. I just want to know whether the automated upload scripting on GitHub was available, and would I be able to use that for the Jules model? Because that's obviously one of the issues we've had. That's why we've done all the analysis offline. So having an automated script that would upload to me.org would be amazing.
So I think the web API is currently, it's still pretty early days. It's in development right now. I think it's working, and we're sort of, I think Ben's working on having BenchCab like communicate through his client that he developed to modelevaluation.org. So I think the API already exists. But yeah, it's still pretty early days, so you might find that stuff's pretty broken, but yeah.